Oh, man, thanks everybody for coming out. Hopefully you had a good time here. And then the tags, that's kind of a fun thing to do. But jumped over like the log taking, that's kind of fun too. So a little bit about me, developing PHP for about 10 years. Got the master's degree in information systems. Senior software engineer, team lead, working on occupational health screening, so this is your random drug testing, pre-employment drug testing, basically managing all that kind of stuff. Biggest project I'm working on currently. Security-wise, SSCP and CSSLP certifications. Spend most of my time in PHP databases and JavaScript, loading outdoors. The topics we're going to cover today: abstracts, of course, interfaces, traits, namespaces, dependency injection. We're going to go into some examples of each of these. We'll look at how they're used, what the purposes are. We won't go intensely deep into each of these, but hopefully we'll broaden an understanding of when to use them and how to use them and what we might be leveraged for. So we're going from breadth, not a ton of depth, but we will cover some stuff that's hopefully very useful. As we go through these, think about your current coding style, think about your current architecture, think about how you're currently coding, where you could plug in some of these items that would help with your code architecture. And set some professional goals to yourself, what you can do to improve over the next few weeks, or months, by the time coming. So, jump right into abstracts. An abstract, if you think about some examples in real life, you have an abstract art. It's something you look at, it's a little vague, and it's something that you can't quite tell what it is necessarily, or it's supposed to be able to represent something, or it's to be polymorph. About an abstract of text, it's just a summary. It just doesn't go into detail. It gives a very rough, high-level overview. You give an abstract thought or an abstract idea, where it's just an idea that comes across. It's not a specific detail, but it can be progressed into something else. Same thing with an abstract class within PHP. The usage of them. If you're going to use abstract classes, you first define the value, say abstract class, X, and you go and do your curly braces and build out your abstract class. And then when you want to use it, you go and say, new class name, class Y, or whatever, extends X, where X is the name of the class, the abstract class. Abstract methods can be inside of an abstract. So this would be, for example, abstract public function, do something. Maybe it's abstract protected function, do this. When you have those abstract methods, you don't put any body inside of them, but the signatures must match when those are used by inheritance. So you won't spell out any details in there, but we'll say signature referring to the method name, variables passed in. You can't instantiate that abstract class because the abstract is not supposed to be instantiated. You can instantiate a concrete class, which is what we'll be using in abstract. That's basically how you use an abstract class. You use these a lot, hopefully, as you go and try to reuse your code. Again, the methods can have functionality, so you don't just have to have abstract functions. You can have actual logic in there. You can do stuff. But when you would be able to instantiate it directly, you'd have to have like something extended. An abstract can have properties. It can have constants. It can have all these kind of things that a normal class would have. It can have traits, for example. It can implement things, interface. It can extend another class. We'll go a little bit later about how far we should abstract, and how many layers, but know that an abstract can extend an abstract class. So you have multiple levels there. And this represents a base idea or base concept. It's important to remember that when you are working on an abstract, you can decide if the classes should be abstract or not based on the is a rule. So is it this? Is it that? If it's not that, then it probably shouldn't extend it. This is probably a fairly common mistake or common issue that you find in code where it's not really that. So for example, I'm not an arm. I wouldn't have a class arm that extends I wouldn't extend a class arm just because that arm would be an example. It's important to remember that is a, can you say X is a Y? Is a truck, a car, or was it? I think those kind of examples. Composition over inheritance. This is going into, we'll go into more dependency injection, vertical, horizontal inheritance. But going into why when a class should be abstract and shouldn't be. Inheritance is when you extend an abstract class, and there's vertical that way, the abstract, you go down the concrete classes. You can go horizontal traits, we'll get into traits and what those are, how those work. Abstracts are very helpful for centralizing the logic. It's a good way to reduce code duplication. So if you have duplicate code and to make updates to it, or there's bugs in it, you have to go fix it everywhere else, right? It reduces that problem, helps solve that problem. Because your code is in one spot. If you write unit tests, you write unit tests against that one spot, you don't have to go write it against all the other spots. It's a good way to centralize your logic. Keep it in one spot rather than having it spread out throughout an application. You're reducing that duplicate code, keeping that duplication down. If you're running any code smells or any mess detections, those will catch those duplicates. It's important though to avoid a maze. I've seen some mazes in code where the inheritance line isn't very easy to understand. The extraction may have gone too far. Maybe it's overly abstracted, or maybe it's not abstracted enough. So it's important to keep this structure there.
Would an example of over abstraction mean you have a whole bunch of abstractions, extending abstractions, yes. And finally you get to your class that you're actually going to use?
Yeah, so
okay.
If you're going to 10 levels, it's probably too far.
Yeah, so it's okay to reduplicate code in those instances because the other side is worse. It's less readable.
You may want to consider how you're doing it. Maybe you want to do composition instead of inheritance at that point. Maybe you want to go into traits and have a trait instead. Has a versus is a situation there.
Mm-hmm.
So I generally keep the levels at most 3 to 5. It's kind of a max on abstraction. Get beyond that, it gets difficult to figure out what's going on. Keep that open, another file, find the functionality. That just helps keep it easier to understand. Yes, you can abstract it out that far. It's easy to figure it out, probably not. Some more examples here. So abstraction, now think of a car. So what does a car do? A car drives. It has a gas pedal, has a steering wheel, has all these different things. Perhaps you think about, so that would be in the abstract, the base class, the ability to turn, the ability to go. Now it's actually implemented out. It's going to be different for each make and model. Every car, a pickup truck's going to drive different than a sedan or a minivan. So you would have the base class of car or truck, and it comes with common functionality, so you can branch those out. Centralizing the logic, keep things together. When you actually go and drive the vehicle, like I said, if you're driving a little car versus something else, it can be completely different, but the functionality can be centralized. A mammal, for example, classifications within animals, fish, bird, they all have common things they do. A bird has feathers, it has wings, it has feet, it has a beak. Those are common functionality items that you can put in abstract. And then when you go and say this specific species is going to go, and it's, maybe it's a penguin, it doesn't fly, but it flaps its wings to swim. It's different for every type of bird, fish, and mammal. The fish, you say, it's going to have gills, it's going to have scales, it's going to have fins, and it goes in the water, it swims. Each one's going to be different. And how it behaves. On the concrete class would be different. Same thing with the computer. The computers have input, output, processing, storage. That's something you can abstract out. That's something all computers do. It's abstract out to that level. And when you go and implement it, it's going to be different. Each computer will behave different. It's going to have different bells and whistles. It's going to have different amount of memory, hard drives, all that kind of stuff. It's going to be different. An actual example of an abstract, this would be a pen. Pens are common. So you have protected, there's a property on the class that has a abstract function that doesn't do anything, because each pen's going to be a different way to use it. Maybe it's a laser pen I'm using here. It's going to be different than a pen you write with. It's still a pen. way you refuel a pen is going to be different. Maybe you twist it in the middle, maybe you take the cap off the end, it's going to be different how you refuel it. That's something that every app, when you build a concrete class, it must have that function inside of it. Anything that's abstract, any abstract function must be implemented later on in the concrete class. And set length, they're all going to have a length, so you build set a length, it's going to be standard between all of them. They're all going to do that. Centralize the code there. Be an example when you can abstract out the code. Any questions about abstracts? We'll go into some more details a bit later on, more examples as we move forward. Interfaces. Does anyone here use interfaces?
Sometimes.
Do you? Okay. I find they're a little bit harder to figure out what to use than abstracts. Abstracts are more natural to use.
Yeah.
I've seen examples of interfaces used almost never, and sometimes when abstract or interfaces are used, almost every single class implements an interface. It just depends on what your project is and how you architect it.
My coworker said the difference between interface and abstract class was the abstract class was useful.
Fair enough. The interface doesn't do anything, right?
Right.
It defines out a contract. It's a way of, if you think about a user interface on an application or a computer interface, USB is a good example. It's an interface. It's a way you go in and put things in. The USB drive, you can hook anything in there, right? Anything that's USB is going to hook into there. It's an interface. The computer doesn't care what it is, but it has a preset standards that it has to do. It has to be able to accept power. It has to be able to do something. It has to match up to that specific hardware specification. The interface is a way to provide that. It communicates. It says, hey, this is how you need to do this. That's not going to tell you how, but it tells you you need to do that. It's a way of connecting those two things together. The example usage for an interface is you define as interface X, and then Y implements X. All methods in an interface must be implemented on the concrete class. Method signatures must match. So if you have exec, the visibility modifier, public, protected, private, sense. The method name must match. The parameters passed in. If you have, if you do type hinting, so if you take this must be this object, must be the same object. So those are all enforced in an interface. So method signatures must match, or else you can get an error. It's not going to work. The methods, again, they're left empty. So there's nothing inside the interface methods. You don't want to, what is it useful? Doesn't really make sense, right? Why don't we use that? You can use it with no logic required, but the methods are reusable. So there's methods. You want to be able to define out the methods, an understanding of what is going to happen. It's more of a contract. I've heard interfaces are used, but you don't trust your coworkers. It's terrible to say that, right?
The only time I've been able to use it is with payment gateways.
Payment gateways.
Where I had to basically make sure that the calls to a payment gateway are always the same, no matter whether you're using CyberSource or AuthNet or something like that, just to make sure that there's no difference.
The biggest benefits of interfaces is the polymorphism, the ability to have an object do stuff that you predefined out. If it's got to be able to do this, it's got to be able to do that. We don't care how it does it, it just needs to be able to do it. Kind of like the USB example, it's got to be able to plug into there. We don't care if it's a fan or a flash drive or whatever. It's got to be able to hook into there though. We don't care how it does it as long as it does it. The class is also one of the big benefits that it can be implemented. A class can implement in multiple interfaces. So you can implement 100 interfaces. It's not very good idea to do that many, but you can if you want to. Usually you'll see one or two. Pretty common. Some examples of auditing would be an example of an interface. Let's say you have a class you want to ensure that's going to be audited, that it has auditing built in. You can go and build out an auditing interface. You don't care if it's audited as long as it does it. Would be an example. Underwater creatures. If you think about maybe in order to live underwater, you got to be able to get oxygen in somehow. Maybe you got to be able to swim. Think more like fish down this line, or it could be a whale or a dolphin. It's got to be able to breathe somehow. It's got to be able to move. It's got to be able to eat. We don't care how, as long as it does. Just fine. I think in the USB we've talked about it a few times. An example. This is a simple example of light. It's just going to do public function shine. public function travel X, Y, and Z. If you were to go and build a class, which we'll see here a little later on, that goes and implements that interface, you would have to have a public function shine that has stuff inside of it, wherever it shines, we don't care, and then be able to travel X, Y, Z. How does light travel? Good question. Still kind of unknown, up to debate. Any questions about interfaces?
No question. What does it mean that the method's signatures? What's the signature?
So the signature of a method is going to be visibility modifier, which is public, private, protected. The name of the method, so travel, the method, and the parameters passed. So it must have $X, $Y, $Z. Nothing more, nothing less, nothing different. It's exactly the same. So that'll be the method's signature. Easily identified. Any other questions? A trait. Traits are fun. Anyone here using traits? You have to have a more current version, PHP 5.4, when traits were introduced. Traits are characteristics of something. I have 2 red-headed sisters. That's a characteristic of them, right? It's not something that they are not a red hair. They're not red hair. You have red hair. It's a characteristic. Something you have, something you possess. It's something that you can pass on, for example. As I mentioned, PHP traits were introduced in PHP 5.4. The example there is you build it basically like you would build a normal concrete class. Trait X, you put stuff in there, and then use X. On the class that uses it, this was inside the class body, you put use X. So then you just match those up. And then you can use it. You can use any of the functionality inside of it. If you have a function call inside there, you can use that. This is where we get into some come down to the horizontal inheritance versus vertical. So an abstract, when you implement an abstract, you extend an abstract, that would be vertical inheritance. When you use a trait, it's horizontal inheritance. So a trait looks a lot like a concrete class. If you didn't look at the definition of it, you wouldn't know the difference usually. It can't be instantiated. You can't go and say new trait. It doesn't work. The only way you can use it is with the use statement. And you'd have a semicolon. Usually you put the trait, if you use a trait, you put it at the top of the class, so it's obvious that you're using traits, and you put group together. You put common functionality, common attributes of functionality within those. Things that don't make sense from the is a rule, that doesn't make sense there. It doesn't make sense to put it in the interface, or I can go to trait. It's a pretty good place for it. It helps with code reusability. Keep vertical inheritance in mind though, because if you have an abstract class or any class that's extended later on, that extended class also has access to the trait. So you have to watch out for naming collisions, anything else like that. Keep that in mind so you don't run into those issues. Reduces some of the limitations of single inheritance, because if you remember, you can only extend one class, you can't extend multiple classes in PHP. You can have a class of extended class, which has already extended a class. You can't extend 2 classes with the same class at the same time. So a trait is a way to get around some of that, if it makes sense to do that. The important thing to consider though with a trait, because it's pulling in all that extra information, remember a class should generally do just one thing. And so you gotta ask yourself, is it a required function for things within the class? If it's not required, it should probably be injected, dependency injection. Just compose it. We'll get to that one a little bit later. But a trait is only when it's required for functionality for that class. You're always going to use that trait in your set that class. Examples. Car tire, right? A car has a tire. It has access to it. You're always going to have a tire on a car. If you don't, there's a problem. Have sparks flying out of your car way down the road. So you can have a trait. A class car, use trait, or use tire. It's going to use the tire. And the class will know what to do with its tires. And you have those tires available to it. It's always going to happen. Underwater creature, going back to this example here, underwater creature is may have specific fins, you know, so maybe you get two sharks and they're going to have shark teeth. It's going to be a characteristic or a trait that it possesses. Example, so here we have a wave, trait wave, has a length, amplitude, and frequency. It has those three things. All waves do. It's going to have a length. You set the getters and setters on there, and it's going to do the wave. I put a nice marquee on there because that's super awesome. All the marquees. But it's a trait, it's a wave. You know, what's going to use the wave? It could be all sorts of different things. It could be water, it could be sound travel, it could be all these different things. So we have this trait that can be used. Any questions about traits?
Yeah, so for instance, you could do a trait tire, and then you would have a car class that uses tire and a truck class that uses tire.
Yes.
And then you could have, you know, a steering wheel trait that you then attach to both of those.
Yes.
Okay. All right.
Yep, you can have as many traits as you want. You have multiple. You can have them, they're reusable. They're reusable, of course, they need.
How do you test classes that are using traits? Like you
Unit
test all the
testing.
methods that the trait implements?
Yeah, so there's PHP unit, you can use get mock for trait, I think it is, or something like that. You can build a mock object for a trait, you know, basically go and extend out the class, or sorry, make a class and just have it use the trait, and you can test that class.
Do you think it's okay to not test those methods though, because they are kind of the methods that the trait adds to that class could potentially be different for each class that inherits that trait, right?
That is true, yes. It depends on what level you want to take unit testing to. In theory, it's covered if you're testing that trait, but it could change the functionality if you have leaving provisions and stuff. So it's a good point. You know, how do you test those? Any other questions or thoughts? Namespaces. Namespaces are so great. PHP 5.3 introduced them. That alone was a reason to upgrade to PHP 5.3. You no longer had class names that were humongously long. You could simplify this. Finally, it was great. This, you know, namespace is a way to container identification. It's a way to encapsulate it. It's a way to group things together. You know, my last name is Niebergall. If someone's last name is Niebergall, I know I'm related to them. It's a common way to we have namespacing essentially at that point. You use a namespace at the top. When you say namespace X, it might be X /Y/Z. Depending on how you do these, it uses the namespace and slashes. So there's a use. And when you go to use that, it's going to be usually just put right after the namespace. But you have to define the namespace. You will say use Y. This will give you reference to other namespaces. You go and define it out. Group the classes. It's a way to group those classes together, bring them together. Shorten up really long class names in your application. You've seen class names like that. They're just humongously long. It's a way to reduce those naming collisions. You go namespace a specific part of your application, and then you don't have to worry about it having the same name of person or customer or product. You got multiple classes named product at that point. You'd have a different namespace to differentiate them.
I had a question about that. So within that, would you then need to rely on aliasing when you're using things of the same product? They're
Yes.
both product, but they're from a different namespace. So it's going to resolve wanting to say like product, : something when making method calls. So you'd have to alias that, right?
Yes, aliasing. So you, on the next slide, you got aliasing, so you use X, Y, Z as X.
Okay.
So just alias it, give another name. I often do it just descriptive a little bit, so maybe it's product model or product service, product entity. I'm going to differentiate between. Good question. It's important because one thing to consider is an autoloader. If you autoload it, if you have your file structure that matches up to the file names, you can automatically include these files and get rid of all your required ones, include ones that they're done. Because you just use the autoloader, it'll automatically load them based on what's requested. So if you're not using autoloader, don't go too far into those, but if you haven't used autoloader, go ahead and go look it up and use those. Basically, it's a way to automatically include the files that are needed at the time they're requested. Watch out for keywords. If you have a class or directory called trait, or case, or switch, or for, or and, or anything like that, it's a keyword, it's going to have a problem. Keep things in mind, going future-proof it, avoid those keywords or those sources. The most common workaround, if you have to call something like that, is make it more generic, or combine words. Maybe if you have a case group or something. Just avoid those keywords. Or if you have classes at work, it's going to be a problem. It must be the very first line of the code, the very first actual code. So you can't have comments above it. You can't have anything above the namespace. The namespace has got to be the very first thing in the file. It's very important. That's all work. Again, the aim of this thing, you just use XYZ, whatever has X. You can name whatever you want. That's keywords. Some example, again, last name is a good way to namespacing. I use, basically, in all my classes, I create our namespace. Everything. Everything's namespace, no longer having these namespace classes. Just about any long name, you just long/name. Be how you reference it. Or if you said use long/name, you just use name. Bob/cat and Jane/cat would be a way to an example of how you do abstract or break those apart and modularize your code. You have two classes named cat, but both Bob and Jane can use them because they are separate from each other because of the namespace breaks them apart. Any other questions about namespace? Namespace again is very helpful. If you're not using them, go ahead and start using them if you're on PHP 5.3. Further, extremely helpful. Generally speaking, use them on every single class. Dependency injection. Dependency injection is a little bit harder one. It's not a PHP keyword. It's more of an architecture, the structure to your application. It's the way you use things. It's the way to send object dependencies into a specific class without the class having to know how to create it. It's a way to pass a service to a client. So the client doesn't have to go to the building to use dependency injection to throw it in. It kind of seems useless until you start getting some details. Why would you ever do that? From an architecture standpoint, it's a very good idea. We'll get to why. Injection by either destructor, setter, or interface. So there are a few ways you can go up. Major help for unit testing. I'm not sure how you do unit testing without dependency injection.
Run kit.
There's got to be workarounds, right? Generally speaking, even unit testing, you want to do dependency injection. It's the easiest way to do it. Unit testing generally build a mock object, which can be passed into the item you want, the object you want to test. It does have some lines of code to have dependency injection. The class is going to be a little bit bigger, but I would argue that the increased file object size is worth it. This is where you could do composition. You can go with composition over inheritance. So rather than extending out a class that doesn't make sense to extend, you're going to pass it in instead. The way to use that, if you're using constructor, which is a pretty common way to use it, in the constructor, you say X, which would be the class name, you want to pass it $X, and then keep going. With all your classes, you need that, with that class, you need to use those. You can also have a setter, so if you maybe have a public function, set X, and you pass it in. It has to be instantiated, and you just set it to the class property. With an interface, you can enforce that it gets set somehow. And you source that's available to the interface. Keep in mind service locators, so maybe there's, you go to get it, you have to use the reference the service locator, you reference the factory to go pull that class that you need at that time. Again, you see PHP units documentation. We won't go too deep into unit testing, but know that there's git mock builder, git mock for an abstract class, and a whole bunch of them for unit testing. It'll go and automatically build a mock object to build a test that item. So when would you use dependency injection? What are some examples? Think about a desktop computer. Who hasn't built a desktop computer, right? I can't tell you how many I've built. It's insane. All those ripping apart, throwing up and stuff. But a desktop computer, what does it have? It has power supply. It has a motherboard. It has RAM. All these different things. It has a video card. That would be an example of dependency injection, because you're going to say, hey, I want to be able to put in this item that needs to be able to work. I'm going to say, I want a video card. Be able to pass in the video card. I have a class that references that. Light bulbs. Well, a light bulb. You want to be able to pass a bulb in. I don't care if it's LED. Maybe it's going to be a regular light bulb. Maybe it's going to be blue. Maybe it's going to be green. Who knows? The lamp class in that case, they have a constructor or setter interface with the ability to pass in a class bulb and set that on the way. So an example here, there's a constructor passing in light and laser. You don't know, maybe you do those, maybe you don't. This is kind of a styling deadline. The getter, in this case, we're going to keep it simple. Just do a new light laser rather than do a service locator or something. And then just going to return it. And then you go to use it, and you say, give me the light laser and shine it. Light laser, if it was passed in, which if you're doing testing, would be passed in right here. Or maybe if you're using the code, if you haven't set it yet, the getter will go and figure out what it needs, and they'll pull it in, set it for you, and you can tell it to shine. It'll do a shine. Similarly with refuel, it's just there. Remember, in this case, it extends the pen, and refuels an abstract method on there, so it's going to be there. Any questions about dependency injection? To the example, so remember that marquee we saw? The marquees are so awesome. So over here we've got, here's that pen, this is the laser, it's using the laser pen, the shining light.
No, on the projector.
Oh, sorry. Good point. Let's think about that. There we go. Because we all love marquees, right? Things that are bouncing, things are old. So we have a laser pen, it's doing the light, or using a laser pen to shine. And the code for that, let's see. So we have, that's kind of a smart. We have a class that has a namespace. So here, it's got the namespace at the top. This is namespace pen. It's going to use light slash to be optional. The required, the autoloader, so we have an autoloader running. And then this is a autoloader registered autoloader. The autoloader is going to go include the files that are going to be necessary. So we don't have to go include a bunch of other references in there. The class laser is going to extend the pen. Because it's a laser pen, it is a pen. Protected light laser. Constructor has a dependency injection coming in. So we have a light laser equals null. Get the light laser, the getter is going to go and pull it. We said you can use source locators, whatever else you need to here. But to keep the example simple, we're just going to instantiate it there. Use the pen. This is where we get the using the laser pen, which is the first line there. Then we say shine. So that shine method is going to do the actual shining, which is there. And then on the refuel, and the abstract method is going and building up. Simple example where it's using a whole bunch of different things that we talked about. It's using the dependency injection, it's using the namespacing, it's using abstraction. Something simple, but it's easy to go change what I need to change in order for this to work, if I want it to work. I'll save you from watching the marquee from keep going. All right, so back to where we were. See the example. There's some major things to consider when we get to using these items, when we get to using dependency injection, abstraction. Things to consider. Why the need for abstract versus interface versus trait. This part is just open to discussion, get feedback and suggestions from what you've seen in your coding. Maybe things you found that work and things that don't. What are some, why the need for all these different items? What have you seen that's worked best and what hasn't worked? With the abstraction, I've seen the ability to reuse that code, be able to get some, then repurpose that, be able to have the abstract code that's already done for you. It's tested in one spot up there. It can be tested. It's easier to test because you get the test there. And then be able to extend it out. Say, wow, I've already got this functionality. It's great. You don't have to go rewrite it all. But it's already done. The interface is going to say, I need to have these methods. Maybe you have a common functionality that's used commonly within your application. From the drug testing world, we get a whole bunch of drug tests back from the labs. We got to say, this result's got to be able to, it's got to be able to do these specific things. It's got to be able to log what's going on. It's got to be able to find the drugs that were tested. It's got to be able to enter the result here. So those are these we put to interfaces so that the code is doing what it needs to do. And again, the traits to address multiple inheritance issues and allow for good use. I've seen mixed thoughts in here. Example, sometimes I've seen the traits in the database that have here as a trait rather than having it injected. It's a different route. There's multiple routes to go there. It could be injected, it could be a trait, it could be something else. It depends on how you architect your code and how you do things. Those are important items to remember. What about the benefits for vertical and horizontal inheritance? What are thoughts that, or examples you've seen for using one or the other? Maybe the vertical inheritance is easier to read. Maybe it makes more sense at that point, the item that you're working on. Thinking back to the examples of the car, it's got the common functionality in one spot. It's not a maze to go figure it out if it's done right. The horizontal inheritance, again, I wouldn't say use traits a terrible lot. Use them sometimes when it's appropriate. Usually I'm using abstracts, interfaces, and using a lot of dependency injection. Tons of dependency injection composition that way. But occasionally, if it seems necessary or appropriate, use a trait. That's a characteristic and attribute that's always going to be used within that class. Traits versus dependency injection. Again, this one comes down to what you're using it for. Generally, dependency injection, you use it. Maybe not all the methods in the class, you need to reference that. So you're going to dependency inject it in because it's not going to be instantiated until you need it. Or the trait, you can make sure it's always going to be used. Because you don't have that extra weight on there, it's not going to be useful. Trade-offs of code complexity versus code reuse. Sometimes, if it's going to be much less complex, it's going to be much easier to figure it out. Perhaps you don't need to go and abstract it out to, out the wazoo, or go make a bunch of interfaces that can make it difficult. And it's something important to remember. It's difficult sometimes to find the right balance, because you want your code to be reusable, you want it to have good architecture. At the same time, you don't want to make it so hard to figure out that, if a coworker has to maintain that, they're going to have no clue what to do with it, because it's so difficult to understand. So that's a very important consideration when you're working on something. Decide if it's going to be useful or not to go out to that level that you're looking at. Use the is a rule when you're extending the class. If you make an abstract class, does it make sense? It is X or Y. If it's not, don't extend it. If it is, go ahead and extend it. It might be reused. That's also important, like, if a new feature comes in, a new feature request, and you want to, the customer wants you to go build out this really cool feature. It's going to be able to get a string in and do some manipulation and send it back out. You're going to go build that out, but are you going to go add on all these extra layers that may or may not be requested? You think, well, what if they want that string to be sent via text message out? We don't need to go build all the extra functionality at that point. So that's a very important consideration when working on that. Any other thoughts or examples or experience you've had with working with dependency injection or abstracts or interfaces that you maybe gotchas you found or stumbled on?
I'm just trying to think of the usage of traits. I guess, would this be a fair characterization? It's probably something that's highly granular in their scope, and so say you were talking about, like, you have a vehicle class that's abstract, and then you have car and truck, and they might, for their drive methods, they both might need tire or something like that. So, but it's like it's shared between them, and it does a lot of stuff. You don't want to necessarily create your own tire object within both of them, because then you've kind of eliminated reusability. That'd be kind of the idea of that.
Yeah, it is. It often is very granular with that, whereas it's not going to be something super abstract. I think an example you gave about red-headed sisters, it's a very specific item, very specific feature, very specific characteristic of them. And you can use multiple traits where needed to address those kind of issues. I guess I try to use abstracts and dense injection a whole bunch. Interfaces sometimes, often, but not all the time. Traits occasionally. That's kind of a general. And you'll look at, if you start poking into frameworks and start poking into how they do things, most often you can do that as well. You're going to have a lot of abstracts. You're going to have a lot of interfaces. They're going to have very, very limited traits. You may or may not see dependency injection in the framework. That's how they do it. But you'll always see auto loading. That'll be very common. And if you're using Composer, which is the package manager, PHP, it's the current best one. It does auto loading for you as well. And you can use namespaces in there now. Any other questions about any of these items that we talked about? Go ahead and give me some feedback if you liked it or not. Let me know what you really thought, what you honestly thought, anything I can do to improve it. Give that feedback. Thank you, everybody.
Thank you.